Welcome to the cosmos, the confines of existence that are governed by space, time, and far more complexity than could ever be described in this brief introduction. Our universe began with a fiery inflationary beginning, which evolved over an expanding space throughout 13.8 billion years worth of time. However, as must all things that have a beginning, there must be an end. This is our universe's future ahead. Previously in this series, we covered the history of our universe's 13.8 billion years of existence thus far. If you haven't seen the first two videos in this series yet, I highly recommend you check those out before watching this video. Also, considering the theories for the end of the universe that we'll be covering in this video significantly pertain to dark matter and dark energy, I highly recommend you check out those videos too. All the links to these videos will be found in the description. But without further ado, let's get started. We will be exploring 4 possible ends to the cosmos as we know it. But before we begin, I'm going to briefly oversimplify what dark matter and dark energy are, due to their critical contributions to the theories we'll be diving into today. From what little we do know about these two entities per se, you can think of dark matter as a mysterious, invisible substance that doesn't interact with anything other than gravity. It only acts as an additional gravitational force upon the fabric of space-time, creating areas in outer space in which baryonic matter is more easily able to clump up, more easily allowing for the formation of stars, galaxies, galactic clusters, and more. Dark matter is thought to compose roughly 27% of the total matter in the universe, compared to the mere 4.7% that baryonic matter makes up, which is the stars, rocks, and all the other visible matter we see throughout the cosmos. Dark energy, on the other hand, composing roughly 68% of the universe, is an invisible expansion force. We don't know why, but it is evenly distributed everywhere throughout the cosmos, even as the universe gets bigger, which has caused the cosmos to start expanding at an accelerating rate. The mystery with these two entities that hasn't yet led us to an irrefutable conclusion as to how the universe most certainly will end is due to there being many unknowns about dark matter and dark energy. For instance, we don't know if the expansion force of dark energy will continue at the rate it is currently expanding everything at, or if it will become weaker or stronger as time progresses. All of these different scenarios vastly reshape the way in which we predict the universe will ultimately end, leading to the 4 main theories we will be discussing momentarily. Our first theory for the end of the cosmos, and the most widely accepted theory thus far, is called the Big Freeze, which is also known as heat death, based on the current trend for how powerful dark energy appears to be right now, expanding the cosmos at a rate of 67.15 plus or minus 1.2 kilometers per second per megaparsec. We expect this scenario to be the most likely, as our universe expands at an accelerating rate over the course of trillions upon trillions of years. All the matter in the cosmos will be spread out. Eventually, all the matter in the universe will be so spread out from everything else that virtually no clump of matter will be within the cosmic horizon of another clump of matter. This means no more stars, galaxies, or even the slightest bit of composite matter will be able to form as the temperature of the universe approaches absolute zero. Not even black holes can withstand the test of time, as even they shrink and decay over time in a process called Hawking radiation. By the notion of many googles of years, that's a 1 followed by 100 zeros, the cosmos will reach a state of maximum entropy, which calls for a cold, dark, empty universe, composed of nothing but fluctuating virtual particles. Nothing can cause the cosmos to become more disordered, as the random dispersion of fluctuating virtual particles render the universe unchangeable. And so for the first time, time becomes meaningless. A great video on this probable outcome of everything as we know it is Melody Sheep's time-lapse of the future, which I'm sure most of you have already seen before. But if you haven't, I'd highly recommend you check it out after this video. However, we're not done with the Big Freeze yet. A peculiar application of the universe ending in a dark, empty state of maximum entropy has to do with time being rendered irrelevant in this scenario, and that this universe is composed solely of randomly fluctuating particles. Normally, in a room full of random fluctuating particles, it would take an absurd amount of time before you see those particles, for instance, randomly assemble a grand piano. And in the case of our universe reaching maximum entropy, it still would take an absurd amount of time. However, since time has been rendered meaningless due to the cosmos becoming unchangeable, it is a guarantee that at one point or another, random fluctuating particles will assemble a grand piano. And this goes for quite literally anything you can imagine. If you can imagine it, it will eventually exist in the final phase of the universe. Not just once though, but an infinite number of times. So by this notion, everything in the history of the universe can happen again, and in such occur an infinite number of times. The Earth, the Sun, the Milky Way galaxy, virtually anything and everything with the test of time shall exist again. Which leads to an interesting concept called the Boltzmann brain hypothesis, explored in a rather interesting video by Kurzgesagt, which I will link in the description. The Boltzmann brain hypothesis asks a question on what if the universe assembled a brain that thinks it's experienced everything in the cosmos. In the case of such a brain being rendered into existence, this would beg the question of whether reality is in fact real, or if everything we perceive to be real is just a memory being replayed within the mind of a cosmological brain. And considering this cosmological brain will be assembled an infinite number of times in a heat-death universe, the chances of everything being just mere memories of a randomly assembled brain is far more likely to be reality than for our universe to actually exist. And so now the question begging for an answer is, does it even make sense to make these assumptions about a heat-death universe? Be sure to leave your thoughts on this in the comments below. Our next theory for the end of the cosmos pertains to the Big Crunch, which used to be the leading candidate just a few decades ago, and was even a theory Einstein bought into. The idea of a Big Crunch is contingent upon the thought that dark energy, even though it is expanding the universe at an accelerating rate right now, happens to be a dynamical field in which at some point in the future could change from an expansion force to a compression force. This unsuspecting turn of events would cause the cosmos to contract to smaller and smaller sizes, causing fiery collisions between massive objects to form more black holes than the universe could possibly know what to do with. Eventually, all the matter in the universe will be compressed into one point, rendering the smallest yet densest black hole to ever exist, containing the greatest point of singularity the cosmos could ever muster. With such great pressure and energy of the entire universe compressed into one spot, it is thought that maybe, as an extension to the Big Crunch, that the Big Bang would occur all over again, causing a complete restart to everything as we know it. This extension to the Big Crunch is sometimes known as the Big Bounce, or as we've previously explored on this channel, the oscillating universe theory. This idea would indicate that our universe exists in cycles in between a Big Bang and a Big Crunch. Not only that, but this idea would also indicate that our universe as we know it may not be the first iteration of the cosmos, as in existing in cycles in between a Big Bang and a Big Crunch could mean that an unknown number of universes oscillated in and out of existence before this one. Ultimately, such a theory condemns the universe to an endless cycle of expanding and contracting for all of time. Our next theory also contains a contingent factor, which also makes this theory less likely to be the outcome of the cosmos. Called the Big Rip, this theory also calls for dark energy to be a dynamical field subject to change over time. However, in this case, it is believed that this expansive force of the universe will get stronger over time, which is a theoretical characteristic coined phantom dark energy. If it is indeed true that dark energy will become more powerful over time, it could then subsequently build up within mass-containing objects over time. And this build-up over time would have severe consequences on the universe as we know it, since the once larger scale effects of dark energy would begin to overtake the forces at play at more local scales. In other words, if phantom dark energy is indeed what the cosmos has in store for us, superclusters, galactic clusters, and galaxies will begin to be ripped apart from the inside. And continuing on this fiery road, gravity would be the first force to be rendered useless. Everything that is even remotely held in some sort of gravitational structure will be dissipated of their normal patterns instantly. But this isn't even the most concerning implications of this theory, as the whole reason dark energy works now in coexisting with mass-filled objects is because it would only have effects on the largest of scales, which normally would just spread everything out from one another. However, as dark energy in this instance gains strength over time, it begins to take over the local effects of not just gravity, but that of the other fundamental forces too. Given enough time on this trend, phantom dark energy would overpower the strong nuclear force, the fundamental force responsible for holding together every atomic nucleus in existence. In an instant, everyone and everything in the entire cosmos would be ripped apart, atom by atom, causing the whole cosmos to explode in a fiery release of the most absurd amount of nuclear energy. Fortunately for us, however, this scenario is very unlikely, considering the idea of the Big Rip and phantom dark energy are thought to violate certain energy rules we believe to be true in the universe. But even if this is the path our universe ends up taking, such a drastic chain of events wouldn't occur for billions upon billions of years from now. So, there is no need to worry about being split into trillions of pieces. For now. Our last possible end to the universe takes a bit of a different approach, called vacuum decay theory. This idea actually comes from data gathered at the Large Hadron Collider. Still not as likely as the Big Freeze. This theory pertains to the Higgs boson, a fundamental particle found in the Standard Model and is associated with the Higgs field. This field gives mass to other fundamental particles on the Standard Model, such as electrons and quarks. In simpler terms, what this theory entails is that the Higgs field holds a certain value of energy. Furthermore, during the Big Bang, when the conditions of the universe were most extreme, we know this important energy value was different from how it is now. This is important because this value for the Higgs field must be the same everywhere due to it governing the intrinsic property of mass that almost every particle contains. So if the value for the Higgs field were to change, it would have to change to the same new value everywhere in the universe, therefore permanently altering the way in which all particles interact with one another. A good analogy for this would be introducing a source of heat into a cold room. Naturally, that source of heat will be dispersed throughout the cold room eventually, evidently raising the temperature of the cold room to some degree. But at the end of the day, The temperature in the room is constantly trying to balance itself out, such that the temperature is ultimately the same everywhere. Tying this back to the vacuum decay theory, it is thought that since the Higgs field changed once in the past, that it could be subject to change again. This process of the Higgs field changing is called symmetry breaking, a turn of events in which the vacuum state of the universe changes to a more preferable vacuum state. This change would imply, as the change during the Big Bang implied, that we currently exist in a false vacuum state. And in changing the value for the Higgs field, the universe would move into a more desirable true vacuum state. The only problem with such a change, as you might have suspected, is that this implies our current universe is, at a fundamental level, not entirely stable. If the current value for the Higgs field is not desirable, then it is only a matter of time before it will change. But this change would permanently alter all the laws of physics as we know it, meaning that absolutely nothing we see in our current universe could exist anymore. If you came into contact with an altered Higgs field, you would instantaneously incinerate as the atoms within your body fundamentally change forever. And with a fundamentally unstable gravitational field in this new reality, the incinerated atoms that previously composed your body would immediately collapse into a black hole. Believe it or not though, it gets worse. Unlike the first three theories, where at least observational data can be taken in advance to predict these possible ends to the universe, in such a case of the vacuum decay theory, you wouldn't be able to see this one coming. It is thought that a changing Higgs field would cause a chain reaction of all the Higgs fields surrounding it to match this new value at the speed of light. In a fiery light of explosions and spontaneously forming black holes, you would never know what hit you until it was too late. And that concludes this series. Thank you all for watching. If you enjoyed this video, please consider liking and hitting that subscribe button with the notification bell on. To learn more about the universe's future ahead, see the links to the research I used for this video in the description. To all of you who have followed this Origins the Cosmos series, you are legendary, and I thank you for joining me in this cosmological journey. Please let me know what series you'd like to see me cover next on this channel in the comments below. Have a great day, everyone, and remember to stay curious.
I'll find valid in your eyes. You'll always be my night sky.